I could, but I'm too tired.
Well, first differentiate.
How do we x-intercepts?
You factor by grouping.
Factor by grouping. Pull out an x squared. What do you got left over?
X, 2x minus.
So 2x minus 3. But with the next two terms, you're going to pull out a.
4.
I can't hear you.
Negative 4.
Hold it. What color do you guys prefer? Green or purple?
Red.
Thank you. Neither. And what's left over is.
This game before.
Is that what it is? A game? I see. I'm offended. Now, pulling out the common red factorial or binomial beast, is this supposed to over blue? As remaining factors standing on either side of subtraction operation, these two beasts? Oh, shoot, you guys, I haven't factored completely. I said, shoot, you guys, I haven't factored completely. I can say thrice.
X minus 2.
X plus 2.
X plus 2.
2x plus 2. Is it getting too late? And I think graphically speaking, x-axis, y-axis, I've got an x-intercept at negative 2 comma 0, positive 2 comma 0, but also 3 halves comma 0. Oh shoot, does it look like I'm off scale? Heck yeah. But who cares? I laid my points clearly. Doesn't make any difference. How do you find the y-intercept?
Set it equal to 0.
Set x equal to 0, state the answer.
12.
Say it again.
12.
I can't hear you. 0, 12. There's a point in 2 space. Right? It's a point. I got an idea. Let's build a sine graph. I think plotting on the real number line the zeros of my original function, like at negative 2, positive 2, positive 3 halves, these three real numbers subdivide the real number line into 4 subintervals. I'll check them. To see if x is positive or negative over each of these intervals, it's getting too late. I'm tired.
Use the odd power and just toggle switch over.
Thank you. I've already found that when x is 0, y is positive. But since each and every one of these three zeros is a 0 of a linear factor raised to an odd power, they each act as a toggle switch. Don't you guys agree? Mm-hmm. And so I know to the left of this x-intercept, my y values are negative. But in between this x-intercept and this x-intercept, my y values are positive. But then they become negative again, and then become positive. Do you think my picture is very accurate?
Yes.
No. I think it's relatively accurate, but maybe I should find the local extrema. Well, you said it right, local maximum. Makes sense. And to find local extrema, I'll differentiate. Can I give myself some room?
Yes.
Told you you're going to need another board. I just made myself enough room. You know, when I first moved to California, I got a job at Hewlett Packard. It was so cool. I go to the board, give presentations, and they didn't have an eraser.
You just keep going.
They had a button in the wall. You push the button, and the whole board goes inside the wall and comes out again. Perfectly clean. It was so cool. We don't have the kind of money here at Sierra.
That is awesome.
It was very awesome. So anyway, to differentiate, I'll let you do it. You can have fun.
6x squared.
Minus 6x minus 8. Pull out a 2. Yeah,
3x squared minus 3x minus 4.
That's a 4, right?
It's a Greek letter.
Sounds good.
Wait, why? What's going on?
3, negative b, plus or minus the square root of b squared minus 4ac, but that would be 48? All over 2a. Or shall I say x is equal to 1/2 plus or minus root 57 over 6?
What happened to your 2?
Well, if I set the first derivative function equal to 0, I can just divide
Oh,
this
I
out.
see.
Makes no difference whatsoever, this constant coefficient.
Sure. Oh, because you said it's equal to 0 right there. Gotcha.
That being the case, I guess this local max occurs at negative 1/2 minus root 57 over 6 comma question mark. And this local min right here occurs at positive 1/2 plus root 57 to be over 6 comma something.
Where'd you get the negative one?
Out of thin air, it's magic.
Okay.
Does that make you feel better? Good.
Wizardry, it's all that.
Oh, you guys, I'm trying to beat the clock again, we're running out of time. Question mark, just pick this up and slap it in for X, right?
No.
No. If I want the Y value, I gotta pick this thing up for X and slap it in for X up here to the original equation to get the Y value. Do you mind if I don't?
No.
Because the
You don't want
the y prime is a whole different graph.
Yeah, as a matter of fact, if I plug this in for Y prime, what do you think I'll get?
0.
I'll get 0 right back anyways. That's how I got that value for X. I said Y prime equals 0. Do you guys agree this function's increasing from negative infinity up to that value for X?
Yes.
And over the interval from that value of X to infinity? And likewise, my function is decreasing from this value of X to this value of X. Do you agree? Okay. All right.
So those are basically the vertices of the,
That makes me so nervous when you use that word vertex. To me, that means I've got either a special point on an ellipse or a hyperbola or parabola or one of my conic sections. And this definitely is not a conic section. This is not a two-dimensional cross-sectional slice of a three-dimensional cone.
okay, I'm just thinking going back to algebra 2.
And you would never see this in algebra 2 without just a expression.
Okay.
Now that it's no longer algebra 2, I'm actually refer to these local extrema instead of vertices.
Not hills and valleys?
Did you use hills and valleys as a phrase in algebra?
Yeah.
Yes.
Where?
Stuff like that.
At Sierra College?
Yes.
Don't tell me that. Where's my book? Oh, there it is. Guys, I have an opportunity to write a really, really cool quiz. Are you ready? Good.
No.
So give me tomorrow or Friday and I'll give you a really cool
Let's do it.
take a quiz. You know what? Across the highway, there was an accident. It shut the electricity to the entire college down. And so we're just out of electricity today. We even had to cancel classes. Yeah, it was just electricity, that's why everything was
Yeah,
down.
it's this morning.
Nothing more. They were doing construction.
So the quiz that you're gonna post is gonna be on 3.9 or 3.10, or which one?
I like 3.10, that's nicer. It's more fun.
You can get a 3-pager out of that one.
I'm not.
Oh yeah,
Oh yeah.
trust me, I'm already there.
That's not gonna be fun.
I'm not evil, I'm providing you with fun opportunities.
Math is evil.
No, it's not. Math is not.
You keep saying that, but it gives me headaches. It requires migraine medication. No other class. Nah, I can't say that. Physics is worse.
Yeah, oh, you wanna?
Well, when you refer to physics as dirty math, what are you implying? Because I don't. Because it's still
I don't know where it is.
a pretty clean approach to use of mathematics. I don't see the dirtiness in it. Because this right here is dirty.
When you use the mathematics and physics, does it have any meaningful interpretation?
Of course.
It's dirty.
What?
You know, I went out last semester. I had one morning, just one morning, the entire semester, I had it free. So I went in my backyard, and I just happened to pick a book on applied mathematics. I said, you know, I'm just going to sit down and read an applied math book. And I opened up, I could not finish the first sentence, when all of a sudden 2 wasps came behind my neck and just stung me like crazy. That's a bad omen. I just shouldn't do this anymore.
Maybe it was a sign that you shouldn't be so hard on students.
Oh, that was bad. That's enough.
Like divine reckoning or something. Good.